Hi everyone, this is video number 1 for our new set of notes. So this is notes A, and it's for checkpoint 1 of our second unit called transformations of functions. So I'm going to go over all the different types of transformations. So first things first, what is our objective today? I'm going to show you that objective, which is here in yellow. Go ahead and pause this video and type this objective in the first box of your notes. So I'll leave that here. The next thing we're going to talk about is this next question: what is a parent function? So whenever we do a transformation, so we're going to take a graph and we're going to flip it, we're going to move it left and right, we're going to move it up and down, but we always have to start somewhere. Our starting point is called a parent function. So the definition of a parent function is here. So again, I want you to pause this video and go ahead and type this in that box. But what the parent function is, it's the simplest form of a function, and it's where everything starts. So we're always going to start here and then do our transformation. So you can see from this picture, which is also in your notes, our parent function is going to be a parabola, and it's going to always start here at 0, right in the middle of our graph. And also our parent function is going to have this equation, y equals x squared. This is that simplest form. Okay, so make sure your slide 1 is filled out with those two things, the objective and the parent function. Now, let's get into our first kind of transformations. Remember, transformations are going to be like shifting or moving our graph. So like this one, we're moving it from the parent function at 0 to the right 3, right? Or this one, moving my parent function at 0 down 5. So this is what I mean by transformations. And we're going to go over 4 main transformations: vertical, which is up and down; horizontal, left and right; reflection, which is like here, where you're flipping it upside down; and then dilations, which is right here, making it skinnier or wider. Okay, so our first transformation is called vertical transformation. So that means either moving our graph up or moving our graph down. Okay, so we are on this slide. So I'm telling you what's happening. I'm telling you that we're moving our parent function up 2. That's our transformation. You're going to make me the equation, and we're going to identify the graph. So let's start with the equation. We are actually always going to start with our parent function. Remember, our parent function's here, y equals x squared. So I'm going to type that in my box, y equals x squared. You can do the up arrow and 2, or remember our little trick on the keyboard is control period, and then we can put the 2 up high. Just make sure you come back down by doing control period again. Okay, so here's our parent function. Here's where we start. Now, I have to show going up 2. Going up 2. So how you show up 2 in an equation is you just say plus 2. You're starting with your parent function. You are moving it up 2. That's all you show. If I said up 5, it would be plus 5. If I said up 7, it'd be plus 7. Okay? Now, on the other end of it, down 2, hopefully you know what that's going to look like just by the up equation. So again, we're going to do our y equals x squared, and I'll make this bigger. And then if we are going down, we just are going to instead say minus 2. So again, it's my parent function, and then I'm going down 2, down 2. Okay, so here are the first 2 types of transformations: how you go up, how you go down. Again, I could say down 7 and it'd be minus 7. I could say down 15, it'd be minus 15. It's always that plus for up and minus for down. Now we need our graphs. What does it look like on a graph to go up 2 or down 2? So what I want you to do in your notes, if you can scroll to the very last slide, actually second to last slide, slide number 19. There are all of these moving pictures. We have to figure out which picture shows up 2 and which picture shows down 2. So you're looking for, it's starting at 0. And let's look for up 2 first. So as you look at all these moving pictures, This one here shows starting at 0 and then sliding up 2. So I want to copy this picture, and I'm going to go ahead and go back to my slide and paste it. So that way when I look back at my notes, I know what it looks like to go up 2. Now let's find my down 2. So back to this slide, I want to look at what starts at 0 and then slides down 2. Well, it's looking like this one right here, the first one. And notice it starts at 0 and then it's sliding down 2. Always starting at 0 and then how it moves. So I'm going to copy that one and then paste it for down 2. So those are my 2 graphs for up 2 and down 2. Okay, let's go to the next slide. So this one is saying, what if I give you the graph and then you have to make the equation? So let's look at example 1. You have to ask yourself, where am I starting? Am I starting at blue? Am I starting at red? You always start at the 0, right? So that's going to be red. I'm starting at red. So how did I move from red to blue? Well, I can count this middle part of my parabola. I'm moving up 1, 2, 3. I'm moving up 3. So I can even put that in this box to start, that I'm going up 3. Right? But then I want you to make an equation. What equation shows up 3? Well, remember, we always start with our parent function, which is y equals x squared. And then how you show up 3 is plus 3. So here's my equation that matches this transformation. My next one over here, example 2, again, always start at 0. So that's my red. And let's see, how did I move from red to blue? Well, I went down this time. 1, 2, 3, 4, 5. So I'm going to first type in that I went down 5. And then I need to make an equation that shows down 5. So I'm going to do my parent function first, y equals x squared. To show down 5, I do minus 5. So here's the equation that matches this transformation. Go ahead and go to the next